Hello. So my friends wanted to know how I created the time lapses of certain scenes in Google Earth Engine, and I wanted to make a video on that. So it's fairly simple, and let's get into it. The place where you'll need to create an account is Google Colab, where you'll write most of your code, and this is fairly simple, and you just need to sign up with your pre-existing Google account. That's it. And you need to make sure that both of your accounts are the same. Like I'm connecting with this account, and that needs to be same with Google Earth Engine as well. That's it. Well, we'll be using Python for the entirety of this project, so we need to install certain dependencies through pip, like ffmpeg python, and EE and Gmap are already there in Google Colab notebook, so we don't need to install them again through pip. And that's it. We need to authenticate ourselves and initialize the project using the project name, which I told you will be using at a later stage. Well, this is the later stage. And then we create a empty map using gmap.map, and we center it around, let's say, uh, I want to do this project majorly centered around India, so we'll use the latitudes and longitude for India, and we'll zoom it to a certain level. You can tune it up according to your need. So 7 would zoom in further, right? So like so. Okay, I'll tell you something interesting about ROI. ROI is region of interest. Region of interest can be drawn by any user on an empty map through these tools on the left of the map, and we can achieve the same effect through code as well, but I feel like drawing is better for a lot of reasons. So we can mark any location as a region of interest. We have to draw a bounding box around it, and we can pick a rectangle or a polygon as a bounding box. So let's pick our location. Let's see this network of water bodies. It's Chaudhar, Jagatpur, Katak. Let's see how they look under a time lapse, and we'll catch the region of interest with a variable. If the region of interest doesn't get registered, we'll have a default geometrical bounding box uh, for that purpose, and we'll add that layer to the map, and we'll center the map around our region of interest. Okay, for now we have everything for building a time lapse. So let's say we'll call it time lapse gmap dot landsat time lapse. We'll use landsat satellite for our time lapse. We'll pass in the region of interest. We'll call the output GIF as landsat time lapse dot GIF. Make sure you have the extension of .gif, and we'll pick a start year. Let's say we pick 2015, end year as 2022. You can pick your years, but the more lengthier the gap between the start year and end year becomes, the more compute expensive the whole building the time lapse becomes. Okay, so start year, end year, and we'll pass in frames per second. Frames per second is how fast the GIF needs to go, and we need to pass in the band information as well. So I'll pick the shortwave infrared, I'll pick the near infrared, and I'll pick the red bands, and I need the title as well. So let's pass in Landsat time lapse as our title. It will be displayed above the GIF, and You can just customize progress bar color. Let's say uh, mark it as blue, white. Okay, and MP4 equals true. We need to be MP4. That's why we needed the ffmpeg Python library. Okay, we'll execute. It'll take a second depending on your start year and your end year. Let's say if a code cell is executed in Colab, it will be marked with a tick. Yeah, it's executed. Let's see how our time lapse looks. Gmap dot show image time lapse. This is how the whole thing looks. Your progress bar is marked with a white colored progress bar. These are the years, and the disturbances you see, these white colored and black colored, they can be clouds, it can be a lot of different things. We'll discuss that later. So to make this quick, I've written the rest of the code and picked out some interesting locations before we go to the next satellite. We'll pick out Sentinel-2 as our next satellite, and as for the location, I've listed them down in this doc, as we'll see. So let's create an empty map, gmap.map, and we'll need the region of interest, which is geometry, bounding box. I'll pass in the first location, and we'll add this region of interest to the map, and we'll call it ROI. This is an empty dictionary. Empty dictionary stands for visualization parameters. We don't need to specify any visualization parameters right now. And let's center the map around this region of interest. Okay, let's see how that map looks like. Map will center around Las Vegas, this tiny box. We forgot to make the map zoom in. We will see how Las Vegas would look like. Takes a second. So 22 years of time lapse. Let's see how Las Vegas has evolved over time. Okay, gmap show image time lapse. Interesting. Next we'll look at Sentinel-2 as a satellite. Sentinel-2, we can create the time lapse the same way. We'll follow the same procedure. We'll create an empty map and we'll add the region of interest, and region of interest is added to the map as a layer, and we'll center the map around the region of interest. And yeah, you can pass in the frequency as in we need the yearly data or monthly data. You can pass in the start date, end date as an addition to specificity. So we have 3 years of data. And one more thing is the resolution of Sentinels are better than Landsat because we have a 10-meter resolution in Sentinel. And one more thing, another thing is start year can be from 2016 because Sentinel-2 was launched around June 2015. So that's it. Resolution would be better. See how that looks like. Next we'll see Modus. Modus time lapses take broader scale data. So we'll take whole of Africa as a region of interest, and it follows the same procedure of mapping, and data comes out of Terra satellite, and band is NDVI. NDVI is normalized difference vegetation index, and it shows how the time lapse will show how the vegetation varies across seasons, if there are seasonal variants, annual variants, and it'll show the greenness vary across the whole continent. Okay, and rest is same. Overlay data is countries. We need broader data. This is how the time lapse looks for Africa from 2000 to 2022. This is how vegetation indices change as a whole. Pretty interesting. So next we'll look at much broader spectrum data. So let's say we'll use satellite as aqua. We'll go from 18 frequencies taken as month, 2 years of data. So we'll see how temperature varies among continents. So let's say this is the time lapse, and you can see the color bar as well depicting different surface temperatures. Okay, next we'll look at GOES time lapses. GOES is my favorite geostationary operational environmental satellite, and it's very specific about timestamps. It's very specific about events and locations, so you cannot play around with like we did in previous satellites. We cannot play around with events and time lapses here. Basic start date and end date remains the same, but we have a timestamp. It's 15 January to 2022, like from 3 to 7, 4 hours of time lapse. 4 hours of time lapse. I think it's Hunga underwater eruption, volcanic eruption, and it had a huge tsunami waves, and that was terrible. But you can visualize it, and the data takes in which satellite to visualize it from, like GOES 16, 17 or 18. GOES 16 is over Atlantic Ocean, and it covers North and South America. GOES 17 covers the Pacific region. It's over the Pacific Ocean, and it covers US, Western US, Australia, Asia, like so. And scan takes in which part of the globe you want to cover, right? So the full disk means entire Earth hemisphere would be covered. Full disk would be covering, and you can pass it as CONUS as well. CONUS would cover the continental US, like so. So let's look how that looks like, and usual frames per second is also passed in. This is the underwater eruption. Okay, we'll pick out another event. So 2021 October 24, from 14 to 1. That's 7 hours. 7 hours of time lapse. 7 hours of time lapse, and then it's like 14 to 24, 10 hours, 11 hours. 11 hours of time lapse. And it's a hurricane. It's a hurricane. I think it's Hurricane Rick 2021. Yeah. You can visualize forest fires as well. Fire time lapse with these red regions are the sources of fire. Pretty interesting. I was saying in the beginning as well, you can pass in region of interest as a bounding box as well. You can pass in a polygon as well. So finally, let's look at the time lapse of huge hemisphere. Alright, that's it, I guess, for me. You can create, I wanted to show you some other ways to create time lapses as well. So you can easily, it takes up a lot of your RAM, but you can visualize time lapses without any code as well here. So check it out. If you want to download, you can easily find out your whole time lapses listed here as files here, because we saved them as we created them. So 1984 to 2022, you can see the time lapse in Google Earth as well. There are several examples you can look at. Okay, it takes up a lot of your RAM. I think I'm good to go now. Thank you for watching. Bye.